Hi everyone. So you are already watched so many video classes of the BSc first semester, third semester, and fifth semester. So this is my BSc fifth semester modulo numerical analysis, in which I take the unit 3 finite differences. A little bit introduction. Professor T.V. Mergoda, assistant professor in Nehru Arts Science and Commerce Degree College, Hubli. So in the finite differences, we need to define what is the argument and entry. Usually you have to be consider the function y equal to f of x. In a function y equal to f of x, for the values of x, we can say x equal to a plus h, a plus 2h, and so on. X equal to a is the initial value, a plus h is the increment in x, that is a increased to a plus h, a plus 2h, and so on. For these values, the corresponding values of y are f of a plus h, f of a plus 2h, and so on. The values of x called argument, and the corresponding values of y, you can say f of a plus 2h, and so on, are called the entry. Next, to go for what is the definition of forward differences. In the forward differences, a symbol delta is used. A symbol delta is used to define for the forward differences. In particular, the forward difference of f of x is defined by delta f of x equal to f of x plus h minus f of x. You may change x as a here, nothing happens. F of a, delta f of a is a f of a plus h minus f of a. And thereafter, if you want to delta f of x plus h, then it is f of x plus 2h minus f of x plus h. That means x is replaced as x plus h in the previous step. We get a delta f of x plus h. Similarly, you can get the delta f of x plus 2h, and so on. So these are the first forward differences. Next, to define the second forward differences, that is delta square f of x, or you can say delta f of x. So delta square f of x is delta of f of x, means f of x, delta f of x is already f of x plus h minus f of x. So delta is applied to the delta f of x. We can get a delta f of x plus h minus delta f of x. So already we have the definition of delta f of x plus h, f of x plus 2h minus f of x plus h. Keep this minus as it is, and then f of x is a f of x plus h minus f of x. So we have delta square f of x. Only one term is the f of x plus 2h, and there are minus two terms of f of x plus h and plus f of x. So this is delta square f of x. This process will continue for the further differences, say third, fourth, fifth, and so on. In general, nth forward difference is obtained by delta raised to n f of x, means delta raised to n minus 1 f of x plus h minus delta raised to n minus 1 f of x. In the above process, you may change the little things if the argument are denoted by x0, x1, x2, x3, and so on, and the corresponding entries are to be taken y0, y1, y2, and so on. Then the first differences in terms of y0, y1 written as delta y0 equal to y1 minus y0, delta y1 equal to y2 minus y1, delta y3 equal to y3 minus y2, and so on to be delta yn is equal to delta yn plus 1 minus yn. So this is about the finite differences of first differences in terms of a y terms. Similarly, the second differences are delta square y0 is a delta of delta y0, that is delta y1 minus delta y0, because delta y0 is a y1 minus y0. So this delta y0 is a y1 minus y0, delta is applied at delta y1 minus delta y0. We know that delta y1 is a y2 minus y1. Keep this minus as it is, delta y0 is a y1 minus y0. So we have the delta square y0, y2 minus 2y1 plus y0. In the same way, we can get the third differences. Delta cube y0 is delta of delta square y0. Already we have the delta square y0, and rewrite that one and apply delta to that. We can get a delta cube y0. So that is y3 minus y2, because delta y2, and 2 times of delta y1 is y2 minus y1 plus delta y0 is y1 minus y0. We have the y3 minus 3y2 plus 3y1 minus y0. Just you have to observe, if it is a square, there are the 3 terms appear. If it is the cube, there are the 4 terms appear. Similarly, if there is the 4 terms, the 5 terms appears. Just like a plus b whole square, there are 3 terms. A plus b whole cube, there are 4 terms. So these terms can be written in terms of a combinations also. If it is y2, 2y1, y0, in terms of combination, 2 combination can be written as 2c0y2, 2c1y1, 2c2y0. Because 2c0 is 1, 2c2 is 1, 2c1 is a 2. Alternatingly plus and minus can be taken. Therefore, in terms of combination, delta square y0 can be written. In terms of combination, delta cube y0, 3 combination can be taken like that: 3c0, 3c1, 3c2 and 3c3. Because 3c0 and 3c1 is a 1, 3c1 is a 3, 3c2 is also 3. So in general, the nth differences obtained by means of a combination delta raised to n y0 is a nc0 yn minus nc1 yn minus 1 plus nc2 yn minus 2 and so on to be plus of minus 1 raised to n ncn yn. So this is the nth differences. Similarly, in the way we can define the backward differences. A symbol del is used for define the backward differences. Delta is for the forward and del is for the backward. In particular, the backward differentiation of difference of f of x is defined as del of f of x is equal to f of x minus f of x minus h. Del of f of x equal to f of x minus f of x minus h. If you want to go for the second backward difference, del square of f of x is equal to del of f of x minus del of f of x minus h. In the same way, we can define the further difference, backward differences. In general, nth backward difference is delta raised to n f of x is del raised to n f of x is del raised to n minus 1 f of x minus del raised to n minus 1 f of x minus h. Now to define the shifting operator E. E is called as the shifting operator. This E is applied to f of x. What it changes, that can be seen. The shifting operator E of f of x is defined as E of f of x is equal to f of x plus h. If E is applied to f of x plus h, then E square f of x means E of f of x plus h is f of x plus 2h. If it is e to the power 1, it is 1h. E to the power 2, 2h. E to the power 3, 3h. In general, e to the power n of f of x is f of x plus nh. It is the shifting operator. In terms of minus, e raised to minus 1 f of x is f of x minus h. E raised to minus 2 f of x is f of x minus 2h, and so on and so forth. E raised to minus n f of x is f of x minus nh. So this is about the shifting property. Next, to go for the some relations between the properties of forward differences. Before that, properties of forward differences. Linear property: delta of a into f of x plus b into g of x is equal to a into delta f of x plus b into delta g of x. Similarly, the delta of constant is always 0. Next, the delta of f of x into g of x, f of x plus h into delta g of x plus g of x into delta f of x. And fourth one, delta of quotient f of x divided by g of x is g of x into delta f of x minus f of x into g of x divided by f of x plus h into g of x. Then the delta raised to m into delta raised to n f of x is delta raised to m plus n f of x. So properties of shifting, or you can say shifting property, linear shifting property: e of f of x plus g of x is directly e of f of x plus e of g of x. It can be minus also. Then the e raised to m into e raised to n f of x is e raised to m plus n f of x. Similarly, we have some relations between delta, del, e and d. Delta has the particular definition, del is the particular definition, e is the particular definition, and this d means differentiation. Delta, forward difference; del, backward difference; e, shifting operator; d is the differentiation. Now see the first relation, that is, prove that e into delta equal to delta into e. Second one, prove that e equal to 1 plus delta. Third one, prove that del equal to 1 minus e raised to minus 1, or e raised to minus 1 equal to 1 minus del. And fourth one, the del equal to delta into e raised to minus 1. And fifth one, that is, prove that e equal to e raised to hd, or hd equal to log e to the base e. where d is the d by dx differentiation. Now to prove the first result, e into delta equal to delta into e. For that, to consider the proof, e into delta f of x has been taken. Keep e as it is. Delta of f of x is f of x plus h minus f of x. Then apply e to the f of x plus h and e to the f of x. What it happens? E of f of x plus h minus e of f of x. We know that e of f of x plus h is f of x plus 2h. And e of f of x is f of x plus h. So this is nothing but the delta f of x plus h. If it is a delta f of x plus h minus f of x. If it is f of x plus 2h minus f of x, written as a delta f of x plus h. This f of x plus h is written as a e into f of x, e of f of x. So we have e into delta f of x equal to delta into e f of x. Eliminate f of x on both the sides. We get a e into delta equal to delta into e. So this is the proof of the first property. Next, to prove the e equal to 1 plus delta. For that, to consider the again delta f of x plus h minus f of x. So we have f of x plus h can be written as e into f of x. Keep this e of f of x as it is. E into f of x minus f of x. Take an f of x common from this one. We get a e minus 1 into f of x. That is delta f of x equal to e minus 1 into f of x. Eliminate f of x on both the sides. We get a delta equal to e minus 1 or e equal to 1 plus delta. Next, to go for the property number 3 or relation 3, del equal to 1 minus e raised to minus 1. Again, for the proof, to take the del of f of x. Del of f of x definition is that says that f of x minus f of x minus h. Keep the first f of x h as it is, and f of x minus h is written as e raised to minus 1 f of x. Take an f of x common. We have a 1 minus e raised to minus 1 in the bracket. Eliminate f of x on both the sides. Therefore, we can get del equal to 1 minus e raised to minus 1. Next, to go for the fourth property, fourth relation, del equal to delta into e raised to minus 1. For that, you can consider the del of f of x again, f of x minus h. So this is nothing but the delta of f of x minus h. Using the definition of delta f of x, we may define this as a delta of f of x minus h, but delta of f of x minus h, to keep that delta as it is, f of x minus h is written as e raised to minus f of x. Eliminate f of x on both the sides. Therefore, del equal to delta into e raised to minus 1. Next, to prove that e equal to e raised to hd, or hd equal to log e to the base small e, where d is the dy dx. For that, you have to consider the proof. For that, to consider the Taylor series of f of x plus h. F of x plus h by Taylor series, it is f of x plus h into f dash x plus h square by 2 factorial into f double dash x plus h cube by 3 factorial into f triple dash x, and so on. Now, so this f of x plus h is written as e of f of x. Keep this f of x as it is. F dash x is the differentiation of f of x. Therefore, f dash x is replaced as a d into f of x plus h square by 2 factorial as it is d square into f of x. So we have f of x, every term in the right side. Taken that f of x as a common, what it happens? E into f of x equal to 1 plus hd into plus hd plus h square by 2 factorial d square plus h cube by 3 factorial d cube, and so on into f of x. Eliminate f of x on both this side. That e equal to e into f of x equal to e raised to hd. This one exponential result by Maclaurin series. E raised to, if it is e raised to x, 1 plus x square by 2 factorial into x square, and so on. Instead of x, it is hd. Therefore, it is e raised to hd. Cancel the f of x on both the side. We get that capital E equal to e raised to hd, or it may hd equal to log e to the base e. So these are the some relations between the delta, del, e, and d. Now, to go further, some important results by means of a theorem. Prove that nth difference of a polynomial function of degree n in x is constant. Prove that nth difference of a polynomial function of degree n in x is constant, and n plus 1th difference of that polynomial is 0. Write the proof. For that, first you have to be consider a function f of x of degree n in terms of a x. That is, f of x is a polynomial of degree n in x, that is a0 into x raised to n plus a1 into x raised to n minus 1 plus a2 into x raised to n minus 2 and so on to be plus an, where a0, a1, a2, a3 and an are constants, and one must be remember this a0 is not equal to 0. Now this f of x, from this we have to be write the delta f of x. What is delta f of x? F of x plus h minus f of x. We know that already what is f of x. Now f of x plus h means replace the x in every term of this expression as x plus h. It leads to the f of x plus h. Minus f of x means keep this expression as it is. Now the simplification. Here there are x plus h raised to n means this bracket has been, one bracket has been explained n plus 1 terms, in which the first term is x raised to n. First term is x raised to n. That a0 x raised to n, this a0 x raised to n cancels. Next term is a nc1, nc0 x raised to n is the first term, nc1 x raised to n minus 1 into h. That will left a0 n h into x raised to n minus 1. Remaining terms, there are so many terms are here. The remaining terms, first term is a0 n into h, a0 n h x raised to n minus 1. Remaining power n minus 1, n minus 2, n minus 3 and so on to be up to n minus 1 terms will comes. So we can write that as a delta f of x equal to a0 n into h into x raised to n minus 1 plus b1 x raised to n minus 2 plus b2 into x raised to n minus 3 plus and so on to be plus bn minus 1. So what you observed, that means in the first difference the x to the power n has been avoided. Immediately the polynomial in degree n reduces to the polynomial in degree n minus 1. So the second difference has been taken where b1, b2, b3, bn minus 1 are also constant, and we observe that after first differences f of x degree reduces n by n minus 1, or delta f of x is a polynomial in x of degree n minus 1. F of x is a polynomial of degree n, delta f of x is a polynomial of degree n minus 1. Similarly, to take a delta square f of x, that a0, this one n minus 1 into h square x raised to n minus 2 will be appear. Remaining terms can be written as c1 x raised to n minus 3 up to cn minus 2, where c1, c2 up to cn minus 2 are the constant. Here it is observed that delta square f of x is a polynomial of degree n minus 2. For the nth differences, it is observed that delta raised to n f of x is a0 into, this is n factorial because n into n minus 1 into n minus 2 into n minus 3 and so on to be the product 3 into 2 into 1 is obtained, and h has been up to h raised to n will be coming. So these are all constant. Therefore, delta raised to n f of x is a constant. That is the proof that a polynomial, nth difference of a polynomial of f of x in degree n of x is a constant. The constant difference can be taken one more step for the difference, that is delta raised to n plus 1 f of x, that is delta of constant is always 0. Therefore, it is the proof. To remember the two more results without the proof, that is delta raised to n f of x is written as f of x plus nh minus n by 1 factorial into f of x plus n minus 1 into h plus n into n minus 1 by 2 factorial into f of x plus n minus 2 into h and so on and so forth to be plus of minus 1 raised to n into f of x. One more result to be remembered by means of Taylor's and shifting property. You did this one. F of x plus nh equal to f of x plus n by 1 factorial into delta f of x plus n into n minus 1 by 2 factorial into delta square f of x and so on so forth, delta raised to n f of x. So you see, these are the some important results in the finite differences. Next to go for the construction of how to construct the forward difference. Construction of forward difference table. So x is given, say the arguments x0, x1, x2, x3 and so on to be x raised to n minus 2, x raised to n minus 1, last term is xn, you can say n terms, n plus 1 terms, and entries corresponding x0 is y0, y1, y2, y3 and so on to be written. So first difference is a delta y and delta y containing the terms delta y0, delta y1, delta yn minus 2 up to delta yn minus 1. If it is n, the last term will be reduces by 1, that is n minus 1. What is the delta y0? It is the difference y1 minus y0. What is delta y1? It is the difference y2 minus y1. Similarly, delta y2, y3 minus y2, and so on so forth to be. What is delta yn minus 2? It is the difference yn minus 1 minus yn minus 2. What is delta yn minus 1? It is the difference yn minus 1. Okay, so this is the first difference. Second difference, delta square y0, delta square y, it containing delta square y0, delta square y1, delta square y2, and up to delta square yn minus 2. So delta square y0 means delta y1 minus delta y0. Delta square y0 means delta y1 minus y0. Next here it comes delta square y1. Delta square y1 is a delta y2 minus delta y1, and so on and so forth. Delta square yn minus 2 is delta yn minus 1 minus delta yn minus 2. In this way, so it is triangular in shape. One by one term reduces by the upper side and lower side, and we approach the delta raised to n y. Delta raised to n y is a delta raised to n y0. So this is the forward difference table. These elements, delta y0, delta square y0, delta raised to n y0, is called the leading forward differences terms. So the first entries in the table, delta y0, delta y square y0, delta raised to n y0, are called the leading forward differences. In the same way, we can construct the backward difference table. That is, x is given, y is given, del y. Del y is a, first one is del y1. Del y1 is not y1 minus y0, it is y0 minus y1. Y0 minus y1. Del y2, y1 minus y2. Similarly, del yn minus 1, yn minus 2 minus yn minus 1. Del yn minus 1 minus yn. So this is the first backward difference. Second backward difference is a del square y2, del y1 minus del y2. And so on so forth to be obtained. So it is del square yn, and so on, the continue up to the nth backward difference is a del raised to n y0. Here the term yn remains same in the backward differences. So the first entries, or you can say last entries in the table, del yn, del square yn, del cube yn, del raised to yn, are called the leading backward differences. So we see that how to construct the difference tables. That means the forward difference table as well as the backward difference table. Next, to go for some examples on finite differences. First, to learn how to construct a finite difference table by means of example. Construct a finite difference table for the function f of x equal to x cube plus x plus 1. X cube plus x plus 1. It is given that where x takes the values 0, 1, 2, 3, 4, 5, 6. So identify the leading forward difference and backward differences from the table. Okay, solution start. Let f of x equal to x cube plus x plus 1 is given. The x has been given that 0, 1, 2, 3, 4, 5, 6. Put x equal to 0 here, 1 here in the f of x, 2, 3, 4, 5, 6. The corresponding values of if it x equal to 0, the corresponding value of f of x is f of 0 is 1. Then the corresponding value of f of 1 is a 3, because x equal to 1, 1 plus 1 plus 1, 3. And f of 2, that is 2 cube is 8, 8 plus 2, 10, 10 plus 1 is 11. Therefore f of 2 is 11. Next, x equal to 3, it is a 3 cube, 27 plus 3, 30 plus 1, 31. Therefore f of 3 is a 31. F of 4 is a 4 cube, 64 plus 4, 68 plus 1, 69. Therefore f of 4 is a 69. Similarly, the f of 5 is a 125 plus 5, 30, 130 plus 1 is a 131. So these are the f of 6 also 223, because 216 plus 6 plus 1 is a 223. So these are the x and corresponding f of x. So the first column of the difference table is x, second column of the difference is a y equal to f of x. So this is the table containing the x, f of x and corresponding difference. X is given 0, 1, 2, 3, 4, 5, 6. Corresponding f of x, we did that one, 1, 3, 11, 31, 16, 131 and 223. So delta y difference 3 minus 1, 2. Delta y0, delta y1 11 minus 3, 8. Delta y2 31 minus 11, 20. Next difference 69 minus 31. Next difference 131 minus 69. Next difference 223 minus 92. Next the delta square y, 8 minus 2 6, 20 minus 8 12, 38 minus 20 18, 62 minus 38 24, 92 minus 62 30. Next the delta cube y, 12 minus 6 6, 18 minus 12 6, 24 minus 18 6, 30 minus 24 6. Next delta raised to 4y, it is no doubt 6 minus 6 0, 6 minus 6 0, 6 minus 6 0. Delta raised to 5 is also 0 minus 0 0, 0 minus 0 0, and delta raised to 6y is a 0. Till the last term I find out here. Here the upper delta y0, delta square y0, delta cube y0, delta raised to 4y0. These are called the leading forward differences. And here it is del yn, del square yn, del cube yn. These are called as the leading backward differences. So we have the leading forward differences are 2 6 6 0, and leading backward differences are 92 30 6 and 0. So this is the method of constructing the table and finding the leading forward differences and leading backward differences. Next to go for the one more example, construct the table of differences for the data below. Construct the table of differences for the data below. X is given and corresponding f of x is given. If x is 0, f of x is 1. If x is 10, f of x is 1.5. If x is 20, f of x is 2.2. If x is 30, f of x is 3.1. If x is 40, it is 4.6 given. So one must observe the x has the constant difference here, 0, 10, 20, 30, 40. There is a 10 difference. Let it be. F of x may be constant difference or may not be constant difference. After constructing the table, here it is the question continues. Evaluate delta square f of 20, delta cube f of 10, and delta raised to 4 f of 0. First to follows this containing x and f of x. X has the corresponding terms 0, 10, 20, 30, 40 called as x0, x1, x2, x3, x4. The corresponding f of x is also given, that is y equal to f of x 1, 1.5, 2.2, 3.1, 4.6 called as y0, y1, y2, y3 and y4. Now to find out the delta y, first difference is a delta y0 1.5 minus 1, 0.5, delta y1 2.2 minus 1.5, 0.7, delta y2 3.1 minus 2.2, 0.9, delta y3 4.6 minus 3.1 is a 1.5. Next difference delta square y 0.7 minus 0.5 is a 0.2, this one 0.2, and delta square y1 0.9 minus 0.7, 0.2, and delta square y2 1.5 minus 0.9 is a 0.6. Next the third difference delta cube y0 is 0.2 minus 0.2 is 0, delta cube y1 is a 0.6 minus 0.2 is 0.4, and delta 4y, fourth difference, 0.4 minus 0 is a 0.4. Now I want to find out the delta square f of 20. Where it is the 20 is here, that is x2. That means delta square f of 20 is nothing but the delta square f of x2. That is delta square f of x2. What is f of x2? F of x2 is nothing but the y2. That means delta square y2. Delta square y2 is how much? 0.6. Similarly, delta cube f of 10. F of 10 is a x1. That is delta cube f of x1 or delta cube y1. What is delta cube y1 is a 0.4. Similarly, delta raised to 4 f of 0. F of 0 is a x0. That is delta 4 f of x0. It is a delta 4 y0. Delta 4 y0 is a 0.4. So this is the method of finding the terms. Next to go further, find a polynomial of degree 3 which takes the values x 0, 1, 2, 3, 4, 5 and the corresponding f of x or y minus 1, 3, 19, 53, 111 and 199. How to construct the polynomial from the given x and y? You have to be observe, use the finite difference table. The difference table is x is given, f of x is given. We prepared the delta y, delta square y, delta cube y and delta raised to 4y. Keeping the leading forward differences in mind, it is minus 1 is a y0, delta y0, delta square y0, delta cube y0 and delta raised to 4 y0. With the help of the Taylor series or by means of a theorem, by formula to go for the polynomial f of a plus nh, f of a plus n by 1 factor into delta f of a plus n into n minus 1 factorial, n minus 1 divided by 2 factorial into delta square f of a. I am not taking the delta cube f of a because delta cube f of a is 0 in the difference. Okay, n into n minus 1 into n minus 2 by 3 factorial into delta cube f of a. So we have a f of x equal to a plus nh can be taken. A is the initial value. In the table, this a is the initial value. A is 0, initial value of x. And h means interval difference. Interval difference 0, 1, 2, 3. The difference is h equal to 1. So we can go for this one. F of a plus nh has the formula. Put x equal to a plus nh, where a is the initial value 0, h is 1, x is the number of terms is x equal to n. So replace where it is the n as a x and a as a 0. A as a 0 means f of 0, that is nothing but the y0. Y0 is a minus 1 from the table. X, because n is x. Delta f of 0 is a 4, leading forward difference. N is replaced x, x into x minus 1 by 2 into 12 from the table, leading difference. X into x minus 1 into x minus 2 by 6, 6. Simplifying this one, we can get the f of x equal to x cube plus 3x square minus 1, which is the required polynomial of degree 3. So this is the method of constructing the polynomial. With the help of the given data, next to go for the one more example. Find the 10th term of 3, 14, 39, 84, 155, 285 by constructing difference table. So there are some terms is given, 6 terms is given. Our idea is to find out the 10th term of this sequential by constructing the difference table. Consider the solution. The x is given 1, 2, 3, 4, 5, 6. There are 6 terms. The corresponding f of x are given 3, 14, 39, 84, 155, 258. To construct the difference table, the x has been written, f of x has been written, delta y has been written, 14 minus 3, 39 minus 14, 84 minus 39, 155 minus 84, 258 minus 155, and so on. Similarly, delta square y, delta cube y, delta raised to 4y has been written. Keep in mind f of 0, delta f of 0, delta square f of 0, delta cube f of 0, the leading forward differences along with the y0. So with the help of this table, use again the formula f of a plus nh is equal to f of a plus n by 1 factorial delta f of a plus n into n minus 1 by 2 factorial into delta square f of a plus n into n minus 1 into n minus 2 by 3 factorial into delta cube f of a, where x equal to a plus nh, where a is the first initial value of a, that is x, that is a equal to 1. Constant interval constant in the table x is h equal to 1. N is a 9 because x equal to 10. Now f of 10 is f of a from the leading difference 3, 9 into 11, put wherever it is, n is a 9, 9 into 9 minus 1 is 8, 9 into 9 minus 1 into 9 minus 2 divided by 6 into delta cube f of 0 is a 6. So we have the f of 10, 1, 1, 1, 1, 0. This is the method of finding the 10th term from the table. Next to go for the another variety of the example. From the difference table, given that y0 is equal to 0, y1 is equal to 35, y2 is equal to 102, and y3 is equal to 206, y4 equal to 352. Our question is to find y5 and y6 using the difference table. So the solution, we have the x, the difference table, the table x, and the table y equal to f of x, and x is 0, 1, 2, 3, 4 is given. Corresponding f of x is 0, 35, 102, 206, 352. The delta y is a 35 minus 0, and the next difference 102 minus 35, and so on and so forth. Similarly, the second difference delta square y up to the 3 difference, it is 32, 37, 42, not 47. Next it is the delta cube y 5, 5, and lastly it is a 0. So this is the fifth term differences has been. Our question is to find out the 5th term and the 6th term. So we have, look at this one, 5 minus 5, 0, or 5 plus 0 is a 5, like that. 37 plus 5 is a 42. Then 42 plus 5 is a 47. 146 plus 47 is a 193. 352 plus 193 is a 545. So this is the fifth term. Similarly, 47 plus 5 is a 47 plus 5 is a 52. 193 plus 52 is a 245. 245 plus 545 is a 790. So this is the sixth term. From the table, it is clear that fifth term is 545 and sixth term is 790. So this is the one more example has been covered. Next, to go for the estimate the missing term in the table. The table has been given. It containing the x and y terms. X is 1, 2, 3, 4, 5, 6, 7 and y is given corresponding 2, 4, 8. This place has been not given 32, 64, 128. How to find out the missing term from the table? Look at this one. Again, to prepare the table, x is 1, 2, 3, 4, 5, 6, 7 I said. F of x is nothing but the y, 2, 4, 8. This term is we don't know. That can be taken as a 32, 64, 128. To find out the delta y, the difference 4 minus 2, 2, 8 minus 4, 4, a minus 8, 32 minus a, 64 minus 32, 32, 128 minus 64, 64. Similarly, delta square y, delta cube y, delta raised to 4y, the difference of the consecutive terms has been written up to the delta raised to 6y has been written. The last term is a 322 minus 20a. This can be taken as a 0. We get the value of a, that is 322 minus 2a equal to 0. 2a equal to 20a equal to 322 or a equal to 322 divided by 20 gives the 16.1 approximately. So we have to be entry as a 16 also, nothing wrong. So next, to find out the again the same problem, missing terms. In the previous table only one term we have did. In this case we have to find out the two missing terms from the table. The x is given, y is given. X is 1, 2, 3, 4, 5. Y is 25, not given. It is the missing term. 49, it is the missing term. 81. For this, construct the table. Solution. The difference table is x is given 1, 2, 3, 4, 5. F of x is 25, where it is not given. First missing term I taken a. 49 keep as it is. Second missing term is a 9. B can be taken and it is 81. Find out the difference. A minus 25, 49 minus a, b minus 49, 81 minus b.